Okay. Hi, everyone. Today, one of my teammates, Jianjian, and I would like to talk about how to leverage the time to love feature, the TTL feature in Presto Local Cache. Before we jump into the discussion today, let me give you folks a quick introduction of Jianjian and I. Both of us are working very actively in the Presto community and the Alacio community. And before we discuss the details of the time to love, the TTL feature in Presto Local Cache, let us give you folks a quick introduction about what is the Presto Local Cache and what it is for. Here is the diagram that explains the architectural design of the Presto Local Cache and its interaction with the Presto worker node and the external storage. In Presto, each Presto worker node is responsible for pulling the data from the remote storage for further processing. And there could be different types of data file formats, like Parquet files, ORC files, CSV files, etc. Those files could be stored in a remote storage, and then the worker node pulls the data back into this node from the remote storage, and then it has corresponding reader classes for each type of data file for processing. For example, we could have Parquet reader, ORC reader, and CSV reader, etc. In the production experience at Meta and Uber, what we have observed is that for some queries, especially for the queries which need to process a large amount of data, the lots of time or lots of resources could be spent on the data fetching part. Meanwhile, nowadays, lots of companies prefer to store their data set into the cloud storage. And then when we pull the data set from those cloud storage, there could be an egress cost. So to reduce the query latency and to reduce the cost, the egress cost from the cloud storage, with the collaboration from Meta and Uber, we developed the Presto Local Cache, which sits in each Presto worker node and cache the most frequently accessed data into the local SSD resources within each worker node. By design, we cache both the data files and the metadata of those data files. And we organize the cached data files into pages, and the default size of each page is 1 megabyte. So in general, when the data has been cached in the local cache, the corresponding Presto reader classes will just read the data information from the local SSD resources without the need of accessing the external storage. Meanwhile, recently, with the joint efforts from Alacio, Uber, and Meta, we published a paper at Usenix ADC 2024 titled Data Caching for Enterprise-Grade Petabyte Scale OLAP, in which we show the power of the local cache to help to improve the system performance and also to enhance the cost efficiency in this paper. And then for the next slide, my teammate Jianjian would like to talk about how to use the TTL feature in Presto Local Cache.
Yeah, thanks, Chunxu. So for TTL, the main motivation for that feature is mainly for meeting the data privacy requirements such as GDPR. As you can imagine, when you use Presto with local cache to read data from the remote storage, there could be a situation that the data is already expired on the remote storage, but it still exists in the Presto local cache. So without TTL, the cache data will still be able to serve the Presto query, which violates the data privacy requirements. So that's the main motivation for us to develop this feature to meet data privacy requirements. How it works is basically very simple. It's just a background thread scanning through all the local cache files and delete all the outdated data depending on the threshold you set. And here's the three properties you would like to know about how to set up the TTL. And also there's a related matrix you can take a look when you enable the TTL feature, such as the page age and how many pages is already invalidated in the local cache. And now I would like to introduce you about two use cases for this TTL feature. One is we talk about the data privacy. So in Meta, their GDPR regulation is 90 hours. And to safely meet their data privacy requirement, the Presto team set 60 hours as the threshold and 1 hour as the scanning interval for TTL. So given that, we have 30 hours buffer for any exceptions when deleting or invalidating the page from the local cache. Also, one of the big tech companies use Presto with local cache in dashboard scenario. They set TTL for cache quick removal purpose. For example, you can imagine that if you have a dashboard for selecting data in the past 3 days, and on Friday, the data for Monday and Tuesday is no longer useful since we only need data from Wednesday to Friday. But since this Monday and Tuesday data is recently used in the query, and we may not able to evict these data through simple cache eviction policy like LRU. So in this scenario, setting TTL would help you to mitigate this case by quickly remove unused data from cache. So we would keep more room for other data in cache to serve the Presto query.